Welcome to RapidDiff's deep dive on the frontend, and this video will cover the server part of the application, and the next video will cover just the client side. So RapidDiff's application is structured into server side and client side, and server side is basically what we render on our Rails application, and this is what you see on the page when you first load it. So this is covering our HTML file initially. So if we disable JavaScript and I reload the page, you will see exactly what the server is rendering when we first open this page. So there is no file browser, there is no controls for the diffs. It's only first 5 div files, and that's it. The rest is constructed on the client using data provided by the server. And the data is provided through data attributes. So if we can see here, data updata. This is how we get our information on the endpoints and some configuration for the application. That's how our file browser gets its own information as well. So here is our mounting point for the application. So this gets completely replaced with client-side component, and it fetches the data and constructs a DOM tree. And the same applies for this element here. It also enhances our div files, so it mounts into this file using this web component, which I'll explain in the second part. But so far we just need to know that the basic stuff and the static stuff comes from the server. And one of the main questions you should need to ask yourself when working on a feature: should it be put on the server, should it be put on the client, or it's a mixture of both? And to answer this question, you need to think about how much of this feature does change with user interaction. So if a feature depends on user interaction heavily, it's probably better to put it only on client side. If it's mostly static, like for example, these div lines, they do not change with application. We cannot change them in any shape or form. Then it's best to keep them on the server to avoid layout shifts. And as you can see here is when I reload the page, there is practically no layout shift. So that's how the page looks with JavaScript disabled, purely coming from the server. And if I'm enabling JavaScript, there are no jumps. The page is fully stable. That's what we want to achieve with RapidDiffs, and you have to be aware of that. So if you see any jumps on the RapidDiffs page, you should figure out a way to avoid that, usually by doing some placeholder hacks like min height, for example, for the file browser, for the app header. And that basically reserves the space for this element, so it doesn't jump when we add elements here. The same is true for the file browser. So the space you see that it consumes, it's actually is coming from the server. So if I go and disable JavaScript again, you would see that the same space is reserved in this area. And we don't have to do any manipulations to get it consistent. So that is quite important to do. Now let's actually revise which pages actually support RapidDiffs. So far we support 4 pages. These are compare revisions, commits, merge request creation, and also merge request itself. So compare revisions and new merge requests, they don't have to use any specific ways to get into RapidDiffs. They have them by default. But for commits and merge requests, at least now in 2025, you have to use feature flags, and you have to also use RapidDiffs equals true query parameter. That's how you get to actually see RapidDiffs. If you remove this parameter, you will see regular diffs, and that's a different experience. Okay, let's now go and see how we render RapidDiffs on the server. So how the process works is that this URL gets passed to a Rails server, and the Rails server has a router This router checks if this URL matches a specific schema, and then it puts this request, redirects this request basically into a controller, and controller is an object that designed specifically to respond to requests. Each controller can have an action, and in our case for merge request, it's the merge request controller, and the action is rapid diffs. So each of the actions can have a template, and your templates are usually located in app views folder. In our case, it was projects merge requests, I think show or diffs. Yeah, in our case, it's diffs. And this template also renders rapid diffs up. Conditionally, that's how we get rapid diffs appear on the page itself. So in order to render rapid diffs, we need to render our view component, which is called rapid diffs app component, and provide it with a presenter. And I'll explain what presenter means a bit later. In the case of merge requests, the rapid diffs component is a little bit more advanced because we enhance it with a slot. So if you worked with Vue, you should be familiar with slots. We have this slot called difflist, and if you say with difflist, this basically defines a slot for this component, and we can enhance and override the behavior of a particular slot in the app component. In this case, we change the usual diff file component with a merge request diff file component. That's how it goes. So let's look at our app component and what it actually does. Okay. So that's our HTML for the app component. And first of all, in order to locate this, you need to go to your app, components, rapid diffs folder. This is the main folder you'll be interacting with when working with rapid diffs. It contains all the Vue logic for the diff files and the rapid diffs application, but it does not contain logic for the diff files themselves. So it doesn't know how to tell if it's a text diff or if it's an image diff. It doesn't know that. It just knows if it's a text diff, we should use our text presentation. If it's an image diff, it should use an image diff representation, but it doesn't know about diff files themselves. I'll show you later where this is handled. So as I've shown you, our app component takes a presenter, and the presenter is our way to grab the data from controller and pass it onto a Vue component. So we want, in order to render our additional elements on the client, so in order to render file browser and these controls and also additional elements on the diff file, we need to provide some data from the server. And we do this by rendering data attributes. So in the case of app component, we have this app data attribute, and it has all the endpoints and configurations that we would need on the client. And what we would do is then we'll grab this from this data attribute, transform and use them on the client, make these requests. That's the basics of how the data is transferred from server to client. So this data is coming from presenter, and let's have a look at how the presenter is actually structured. So in a controller, in your controller action, you will have to create this presenter. This is, by the way, already done for all the pages, so you don't have to do it yourself. I'm just explaining how it works. So we understand the flow. So it grabs some data from the controller context. So in our case, it's merge requests, diff view, diff options, and creates a new object that's called presenter, and it has some basic data to use for the rapid diffs application. So it's usually endpoints and some configuration, like should we sort the diff files, and also lazy loading. Then our application grabs this data. In our case, we are just delegating it directly to presenter. So all the endpoints are delegated here, and then we provide it through through the controller to the component, then from the component to the actual markup, and we grab it on the client. That's the whole flow of how this works. And we have the same presenters defined for all other pages. So merge request presenter gets its own presenter and other pages get their own. They are pretty similar. It's usually just endpoints, maybe some configuration like offsets, but the core is pretty similar. Okay. You can also see a way of passing data from the client to the server in this case. Let's actually look at it. So we cannot just pass data from server to client. We can do it vice versa. We can pass the data, or you should say, you can pass your state from client to the server using cookies. So for example, here we have cookies for file browser. And this is exactly how we achieve zero layout shift on the server. So we store this cookie preference. So each time I change my file browser, it stores a cookie on the client, and this cookie is sent with every request on the server. So this file browser visible, if I collapse it, it will eventually change it to false and expand, change it to true. So that's how it works. If I change the size of the file browser, it also updates. And this information is sent to the server through cookies. So we have two-way communication between client and server. All right. So when we load the page initially, you would see only 5 files if you had no JavaScript enabled. Let's reproduce it here. So this is our first file, second, third, fourth, and fifth file. No, nothing else. So how do we actually get the rest of the files? And that's where we get to leverage the streaming approach that is basically used throughout Rapid Diffs. Streaming is essentially doing a secondary request to a server and receiving this portion of files, like just these elements, from the server in smaller chunks. So we don't serve the whole thing. We don't serve like 25 files in a single request. We serve 25 files one by one, or in sequence of 5 files. And that's how we get great performance on this page. It's purely an HTML response. So if you go and see the diff stream response, it's just an HTML, nothing else. But if you can look at the scroll bar, it actually shrinks because we add more and more files over time. And if you look at the request, you can see how it streams the diffs over time. So the content download time is the actual time it took for us to stream all the diff files. And the waiting time is the time we took to process your project, process your merge request or your commit, and grab all the diffs data, etc., etc. So it's an overhead we cannot avoid. But after we grab all this data, we can actually start streaming your diffs. So this is how it works on the HTTP side. And I also cover how it works on the server. In the next video, we'll cover how it works on the client. So on the server, we have this streaming resource called Rapid Diff Streaming Resource, and you could think of it as of a mixin, sort of a mixin. When you add this module to a controller, it creates this diffs endpoint, and that's how you tell a specific page that it can also stream your diffs. So when you add it to a specific controller, this controller can now do the diff stream responses. And what it does, it also collects your diffs. So in our case, it's diffs for streaming. And for each diff file, we do render a diff file component. It's also the same component that is rendered in the application. And this component is provided with a diff file and a configuration for the view. And I'll just go over this starting from the application first. So what app component does on the server is rendering our app shell and also rendering some of the initial files. In some cases, we might actually not render anything on the page because the page is not rendering diffs initially. For example, our merge request creation form, it doesn't have diffs rendered by default. So when you open it, you will see overview selected, but there are no diffs. And it doesn't make a lot of sense to start rendering them unless the user clicks the button. So that's when we have this lazy mode. And it essentially means once the button is clicked, you should start rendering diffs only after that. But without lazy loading, we do a bunch of stuff. So let's get through it. First of all, we add these startup calls. These startup calls do insert our requests at the very top of the page. If you look at our HTML, like it's right in the header element. So as soon as the server returns our initial HTML, we start doing this request without waiting for JavaScript, which is super fast. It's a lot faster than we would do our regular requests. But it doesn't mean that we don't have to do them. So if you see us requesting this endpoint, you still have to request it in your code. But startup call basically allows it to be done sooner, and we just reuse the cached response. We also do the same thing for streaming, but streaming is a little bit different because it's using fetch. It doesn't use Axios or XML HTTP request. And we cache this response and then use it later on the client. So all of these three crucial requests are done as soon as possible to get best perceived performance. Then we render our main application. You can always find it by looking at the data attributes. So in our case, this is data rapid diffs. That's how you tell it's a rapid diffs application. It should always come with an app data attribute, which is essentially a JSON, stringified JSON. Then we grab this data on the client and use it to populate other elements. Then render our placeholders for the file browser, for our view settings. And then we render actual diffs. So if we have 0 diffs, we render the empty state component. But if we do have some diffs, we grab this diff slice, which is essentially maximum 5 diff files array, and pass it to another diff file component. And we also provide an element for the streaming. So streaming mounts into this element and adds elements inside here. And lastly, we measure the performance. It took us to render the first 5 files on the page. So that's the basics of how it works. Let's go into the diff file component then. So diff file component is deciding how we should render a specific diff file. And it does so by looking at the diff file object it's provided. And this object has some methods like, is it an OPreview file? Is it a text file? Is it an image file? And then we decide which viewer we should use. So the whole file is basically 2 components. The first component is a header component, and the second one is our viewer component. And viewer is what actually presents the diff. The diff file has all these methods, and you can look them up in this GitLab diff file RB file. So this is actually what you will receive in your rapid diffs application and also in streaming. This is the diff file class. You can look at it at the top. And it has all the required params for us. It also has like file identifiers. And it's a really useful class that allows us to keep our view layer really slim and keep all the actual business logic here. So this file receives, this file component receives a diff file instance that has this methods, and we decide on the which viewer we should use for that. And if you look at the diff file, it might look pretty similar to the XAML template, right? If we go to application, for example, and if we go to our diff file component, these are XAML files, but they are pretty different from what you see, for example, in our views. So here, when we go to the views, it has a different view context, and view context is essentially the stuff that you can use in your template, similar to a view template, right? So in view template, you can write, for example, foo, and foo will be your variable defined in the component. Here we do the same by saying equals foo, and foo must be defined on the controller. So the view context of the regular XAML template is your controller action. But in view components, your view context is essentially your view component class. So each time you see like header, default header, that usually means it's a method defined inside a view component in the rapid diffs. So if you'd like to use any of the controller variables, you cannot use them here directly. You would have to go to the presenter, pass them to the presenter, pass them from the presenter to your application component, and then pass it down to your required component, for example, diff file. So that's a flow that you have to respect. It's also different from how you use your helpers. So let's look maybe at some of the examples how a helper is used. Let's see, form errors is a helper. Yeah. So form errors is a helper. A helper function is a function that you can use almost anywhere, but usually in XAML templates. And you can also use them inside view components. But in order to use them in view components, you have to call it through helpers global object. Let's look at our app component to show you an example. So here's a good example here. Cookies is actually a helper. And you call it by writing helpers first, then .cookies, and that's how you get it here. It's also true for some of the URLs. So as you can see here, API user preferences path is retrieved through helpers, but some paths don't require that, usually built-in paths. So for example, project bluff diffs diff file lines path, it doesn't actually have to be using helpers. That's because view components look up all the helpers for routing and provide a sort of a way to use them without helpers. So this is kind of a magical way of how view components deal with routing helpers, but the rest of the helpers, they must use helpers object. All right, so each time you provide some data attributes from the server to the client, you must use .json. So what I find works best is to just provide a raw object in the component context itself, and then convert it to JSON later in the XAML template. You can also see there are multiple layers to how we send the data to the client. So we have the first upmost level, which is our application. This is our application data. Then we can send data for the specific file. So here, for example, in order to expand lines, we need to know which URL to call. And we provide this URL right from the diff file. So our client goes and retrieves this URL and uses it to expand the file. So this is using this endpoint defined in the file, right? If you can see here, the diff lines endpoint used here exactly matches the endpoint defined here. But we add some params on the client so it properly works. And you also can provide some parameters right from the viewer. As an example, we have this image view component. It also has some data provided from the viewer, and that's how we display the images on the diff itself. So initially, when we load the tab with the images, you would see this loading image diff message, and only then you will see images. And it's one of the cases when it makes more sense to render this stuff on the client than on the server, because you can see the diff presentation is very different depending on the diff state. So deleted and added files have no controls. And for example, changed images get these controls that allow us to change the methods of comparing these images. And also these calculations for dimensions are performed client side. So we don't know widths and heights before we load the image. And all of this stuff has to be accounted for when you work on a feature. So in this particular case, it made more sense to render this on the client for now. All right. Let's also look at our text diffs again. So we have our bigger diff here, right? And let's go through the whole flow, how it's actually rendered. So for a text diff file, we have this condition. If it's a diffable text, we render it either using parallel view or inline view. So parallel view is when you say use side-by-side comparison or inline comparison. Let's go and see how the parallel looks first. And you can see it's scoped inside the text viewers. So how it works is that viewers is essentially a namespace, but it in Ruby, they call it a module, but I think of this more as of a namespace. So when we go to a viewer, we will go to a rapid diffs namespace, then it's a viewer's namespace and a text namespace. And it perfectly corresponds with the folder structure when you open this file. So that's how you can locate it also just by looking at the call here. And our parallel component does just one thing. It grabs our hunks and renders them using parallel hunk component. So what are hunks? If we try and modify this file, and then, oh, okay, I already have a diff file here. So let's repeat it again. So when I call a git diff, you could see that diff is structured in the following way. Then we have first our header, which says which file we are comparing, our commits, so our refs, and the paths. And then we have a part which is called hunk, and hunk is split into our hunk lines and hunk header. And that perfectly matches how it's called in our rapid diffs implementation. If you look here, we can see that this part is called hunk header, the gray one. This is essentially this part. And then we have our hunk lines, each rendered in a separate row in a table. And we are using tables here, by the way, because of accessibility and semantics. So you will have to align with the table structure when you're working on any feature. So that's how we render this stuff. We grab these hunks, and there can be multiple hunks in a single diff. So for example, this device API MD can have like 1, 2, 3, 4, 5, 6 different hunks. And you are dividing them basically by looking at the header, right? So each hunk is a separate render on the server. And they are delivered from the diff file class that I shown you before. So this is the same diff file class that we visited. It has this viewer hunks method that grabs all the lines and converts them into hunks. And hunks are designed specifically for rapid diffs. Because when you go and see how the hunk is rendered, you can see the benefits of using this abstraction called a hunk. Let's see, for example, parallel hunk receives a hunk header and hunk lines, which exactly corresponds to the physical diff representation, like the row diff. And by having this hunk abstraction, we can reuse this data in an inline hunk. So if we switch between those, they're pretty similar, right? But because the layout is quite different, we have to have multiple components. But by having the same data, we don't have to define it twice. So parallel hunk doesn't actually define the hunks. It doesn't know how the hunks are created. We just pass it. If we didn't have this abstraction, it would have to go and construct the hunks. Then we repeat the same process here. But by using this abstraction, it's not needed. And so hunks just grabs your lines. In the case of parallel view, we have parallel lines. So we have the left side and we also have the right side. And each side receives its own controls. So it has the line number here, and it also has line content. And the same is true for the inline hunk. So because it's using just two columns, numbers and lines, we render line number for the old and new line and the line content. So the most of the logic is shared. As you can see, like line number component is shared with the parallel hunk as well as the line content, which is also true for the expansion buttons here. The same component. All right, and one more thing about using view components here. We can actually go and have a look at the expand lines component. You can see that it renders a button, but this button has a data click attribute. That's how we tell our client that this element is clickable, and expand lines is how you detect which type of click was triggered and handle that on the client respectively. I will explain in the second video how that works in detail. But so far, if you want to add any new button on this page or at any given place inside the diff file, you should use data click. This is only true when we are inside a diff file element. So when we are working inside this diff file, right? And our diff file perfectly corresponds to diff file component on the server. Inside it, you should use data click. Okay, let's go over testing the components, because it's not straightforward as you might think. Actually, let's go and start with diff file, because I think it's one of the good examples here. So when you're testing your view components, you should test just for one thing. It's your HTML output. That's what we do here. We call render inline. It's a helper function for view components to render elements in the specs, and we get described class. And described class is essentially saying grab this class and put it here. That's all it does. And provide it with a diff file. And the same as with you can use mocks. For example, here, in order to create a fake diff file, we say build diff file, and it will create a diff file that's not a real diff, but it will mostly work the same. So there will be no repository, there will be no actual merge request, but the mocks all will be in place. And for example, here we test that our diff file can actually support custom headers with slots. So what we do is we actually render this component using header slot. In order to render slot, we call with header inside this block. And C is our component instance. So when you see C, you should think it of as just this class instance, right? So it has all these methods available if they are not private, and we can call them. And then we render our custom header and check that it was actually rendered. So that's how we check the slot. But as you can see, it doesn't have a lot of tests here, right? Even though the component has some logic and it also renders all the text files, all the images, all like no preview component when we don't support this type of div. You don't see the specs here. That's because what we do here is we just test the basic logic of this component. So it's the same approach with Vue. So with Vue, you have two ways of testing. You have shallow mount and you have regular mount. By default, when you render using render inline, it's always full mount. You render the whole tree. But for components like div file, this is usually not required. So you would have to skip some of the components using shallow mount. And shallow mount is quite different in Vue component testing. It works by calling this function, allow next instance of, and providing a component. Then you can provide the arguments it expects, and inside the block, you define the behavior. In order to replace the output of the file header component, you have to say allow instance to receive render in. This is the crucial part. And then you return your HTML just as text. And then you check that it was actually rendered. This is a little bit more verbose than shallow mount in Vue, because in shallow mount, using Vue, you just already have these stubs. So in Vue example, it will be called div file header component stub, but it's not yet implemented in Vue component right now, so you have to do it manually. If you forget how to do this, always return back to the div file component spec and just copy this. And I think these are the basics of the testing. So you cover all the stuff that you are doing in your template. So when you look at your template, you should check all the stuff that is happening here. If you're rendering slots, check that they're working. If you're rendering some elements, also check them. Some attributes that are important, for example, for client side. For example, in our app application, it's really important that we have these data attributes because that's where we mount our client stuff. So we should check those. And because of that, the app component spec is quite big. And it also is used as a mount testing approach example. So we render the whole thing here. We render actual diffs. We render all the elements that you would expect inside this application. That's because the app application is really important and we don't want to changes inside the div file break the whole app. That's why we render it as a sort of an integration test. And that's the basics of our testing. And we have two things remaining. The first thing is styling. We have the rapid diffs. Let me see. We have this components folder in the style sheets. That's where we define all the styles that are used on rapid diffs. This is our index file that is included on every single page that is using rapid diffs. So if you add any more style sheets, you need to import it here as well. Otherwise, it won't be included. And we have all the styles here for application, for the div file, some of the states that we can see, the image viewer, the text file viewer, and no preview. And that's all the basics. to explain to you how we actually write the styles, you should always prefix it with rd dash. That's how we tell it's a rapid diff specific style. You should try to avoid ever using styles outside of rd. So we have probably 1 or 2 examples of that when we have legacy elements. So for example, the file browser, it's actually an element that is not included in rapid diffs. It's using our existing diffs. So it doesn't have all the RD classes. It has this diff released, some tailwind, etc., etc. You should avoid using any of these classes in rapid diff styles. So if you are inside rapid diffs, stick to RD classes as much as possible, if you can. If you cannot, then you should probably leave a comment why it's not possible to do that. And also, when you write your classes and when you write your styles, try to avoid tailwind on the diff file itself, because we plan to cache it on the server. In order to cache this, we need to keep our HTML as lean as possible. And also, it's important for streaming. So for example, when we stream our request, if we look at the size of this request, it was like 675 kilobytes. Imagine if we use tailwind here, it will be 3-5 times bigger, because each style will be added on each element. It will be just enormously large. So when you're working with the diff file, avoid tailwind at any cost. Just use your regular CSS and you should be good. And for the naming, I suggest you never use cascade unless it's important. So for example, when we need to define the behavior for the header, but it depends on another element, I think it's reasonable to use the cascade. But in any other case, just use one level of class definition. Don't nest stuff unless it's really has to be done so. Yeah, I won't go over details how all of this works because it will take me another hour to explain all of this. Instead, I'll just go and show you how we add a simple feature as the last element of this deep dive. So first of all, let's just add a new button right here, right in the header department of the diff file. So we will need to locate our diff file, look at it, and see that it has a header and the default header. So header is the slot, right? Render span means this component can render a slot, and when you do so, it creates a method called the same name. So this component now has a method called header, and that is what is used here. But we also have a default header. So if a header is not provided, we will use our default header. And default header is using this header component. Let's look at it. And let's look at the markup. Let's look at the sections that we have here. So we have our toggle, we have our main section, and we have our info section. I think we would like to add a new button in the info section. And what I'll do is I'll grab our existing button here and just render it in place. And maybe I will add some text saying hello world. Okay, I think that should be it, if I'm not wrong. Just to double check, let's look if it should use the block or not. Yeah, it should use the block. So let's see if it worked. Because I don't have hot reloading on Rails, I need to manually restart it. Also, while it's working, let's also add another feature. Since we are in the header, we have this menu for edit. Let's add another element here. So let's look how it works. This is our file options, it's called. File options menu. And it's actually created on the client side. So the dropdown itself is not created on the server. It's just providing some data using this element. And it has menu items. And that's exactly where we need to add our items. So I would say we grab this. And that's another object here. And let's check what we do in additional menu items, because I don't remember this stuff. Right, so this has text, ref, and position. So we'll do just that. We'll just add another text here, ABC, ref, it just be full, right? And let's restart again. And hopefully we should see a button and a new item in this location. Yeah, it should be ready any moment now. All right, I think I did a mistake here. So maybe it should be just one asterisk, right? I'm not that well versed with Ruby, as you can see. I think it should be good this time. And also, by the way, we also have a way to override the styles that are defined here. Let's actually look at it. Rapid diffs. Yeah. So we have page bundles that are creating the styles. So page bundle is actually how the styles land on the page. And each page can override some of the styles by using CSS variables. So for example, on the commits page, we defined a different sticky top offset. That is because on each page, we have a different header size. So for example, on merge request, it's breadcrumbs and also this big chunk of header. And when we go past, it will change. So merge requests, let's look at merge request diffs. Yeah, as you can see, it's different. It's also different on the breakpoint, and on commits, this header also will be different. That's how we configure some of the styles depending on which page we are looking at. So if you're having troubles with specific page, you can always go to a page bundle and do some configuration here. But please don't try to override it like doing top 0. Prefer using custom variables because that's how you control this stuff without breaking other pages or the code in general. So we have our button, right? So it's regular button added with the server. We didn't have to do anything else. And we also have our menu option coming right from the server. And we also didn't have to do anything on the client in order for this to work. So that's how you work on the features on the server side. So see you in the client side video next. Bye.